Hi everybody, this is lesson 2 in unit 3, proving lines parallel. It's going to feel really similar to last lesson, which is good review, but there is a small difference between today and yesterday. Now, recall from unit 2, we learned how to write the converse of a conditional statement. This is going to come back today. So review at the top, say that you've got this conditional statement. If Allie passed the class, then she got a 60% or above. Remember, the converse is just when you flip the statement and you write the conclusion first, then the hypothesis. So if I wrote the converse here, it would say if, and I'll use my name, just so it reads better, I'll say if Allie got a 60% or above, then she passed the class. Okay, so converse, flip it. Now, last lesson, remember, we learned about AIAs, SSIs, and corresponding angles. And we learned about 3 properties of those angles when the lines that your transversal cuts are parallel. Now, today, we're going to look at those same postulates and theorems, but this time we're going to look at the converses of those postulates and theorems. All 3 properties we wrote yesterday were in conditional statement form. So let's first, and I've grouped them together here. So we're talking about like one thing for each type of angle. And the first is corresponding angles. And remember that this guy is a postulate. It was a postulate yesterday, it's a postulate today. We just accept that this is true. Now, remember we talked about last time that if your 2 lines that your transversal is cutting, if they're parallel, corresponding angles are always congruent. If those lines are parallel, there's a condition here. Now, the converse of that statement, if I just flipped it around, that would read if corresponding angles are congruent, I'm going to symbolize congruent there. If corresponding angles are congruent, then, and I would write the first part then, 2 lines are parallel. And there's the symbol for parallel, so just note I'm using the symbols here just to kind of make it a little bit shorter for myself. So all I did was I flipped that postulate around, and we called that the converse of the corresponding angles postulate. This is going to feel like the same thing as yesterday, but the order of how we're looking at the problem is reversed. So here's a picture. Yesterday, you had the lines marked parallel on the picture, and you had to tell me those corresponding angles were the same. Today is the reverse of that. Look at the picture. They're marking 1 and 2 congruent, or corresponding angles congruent. So we're actually looking at the converse here. I'm noticing, oh, corresponding angles are congruent. So if that condition's holding true, the hypothesis, I know that the 2 lines are parallel. And out of the 3 lines on the picture, use your common sense. It'd have to be the lines going in the same direction. I could conclude that L was parallel to M. It kind of feels like the same thing because it kind of is, but it's just backwards. Now, next you've got what's called, and I guess we looked at it yesterday, the alternate interior angles theorem. And this is a theorem. We proved it yesterday. We could prove the converse today. We're not going to. Now, yesterday, the alternate interior angles theorem, AIA, said if 2 lines are parallel in that same situation, you know that AIAs are also congruent, just like correspondings were. So if I wrote the converse of that, it would say if AIAs are congruent, abbreviating to the max here. So if AIAs are congruent, then 2 lines are parallel. Now, here's all that's saying. And it's the same idea as last time, guys. Don't like overcomplicate this in your mind. It's kind of complicated. I guess I shouldn't say that. Say you've got this picture here, and if I'm looking at the converse of the AIA theorem, they're going to show me on the picture AIAs being the same. So let's say maybe this guy is 60 degrees and that guy is 60 degrees. Those are alternate interior angles. If they are marked or shown to be the same, then I know that the two lines on this picture have to be parallel. Okay, that's all the converse of that theorem says. The last one is going to be the converse of the same side interior angles theorem. And yesterday we said if two lines are parallel, SSIs, these are the only ones that are not congruent. They are supplementary when the lines are parallel. So the converse of that statement would say if SSIs are supplementary or 180 together, then I know the two lines are parallel. And we'll give you a picture just to kind of like visualize this one too. So the difference today is instead of the lines being marked parallel, they're going to show you the angles, something about the angles. This one is SSIs being supplementary. So remember, these are angles on the same side of your transversal on the interior. So let's do like 60 again, but then let's say that guy is 120. Ooh, that's kind of hard to read, sorry. 120 and 60. Okay, I see those are same side interiors, and they're adding to be 180, so they're supplementary. So then that shows me that these two lines are parallel. These are theorems. We proved the first one yesterday. We could prove the converse now, but we're not going to. We just want to get the information down. Okay, it's kind of a lot of the same thing, but here's the difference. Notice that yesterday we were given that the lines were parallel. Like all the pictures that we saw, if we were asked to find like a missing angle, the lines were marked parallel. Okay, and we found or concluded something about the angles. We found X, we found angle 1, whatever. Today is going to be the exact opposite. You're going to be given something about the angles, and then we conclude that the lines are parallel or not. I guess I should say or not. Lines are parallel or not. Now, you have to be able to tell the difference between the two. Okay, so if you're given the lines are parallel, you say something about the angles, that's the regular theorem or postulate. If you're given something about the angles and you tell me the lines are parallel or not, that's the converse. Okay, I'm gonna put or not in parentheses because most of the time you say like, okay, yeah, the lines are parallel, which ones? Okay, I know this is a lot, but this stuff just takes practice, so let's just get right to that. So on the back it says, which lines, if any, must be parallel if angle 1 is congruent to angle 2? Justify your answer with a theorem or a postulate. Okay, so I'm looking for angle pairs. That's what I do every time on these. And sorry, this did not copy very well, but they tell me angle 1 is congruent to angle 2. So here's angle 1, here's angle 2. I need to figure out if that's one of my angle pairs, corresponding AIA or SSIs. So, and also on this situation, guys, there's 4 lines. For me, these problems are so much easier if there's 3 lines. So 1 line is not being used when I just look at angle 1 and angle 2. So here's how I figure out which line I can ignore. If I extend like angle 1 here, I look at this line and I look at this line. If I extend angle 2, I'm also including this line right here. So basically this top line does not matter at all if I'm just looking at angle 1 and angle 2. Okay, so if I look at this picture, I notice these are on the interior. They're in between the lines going in the same direction, and they're on alternating sides of your transversal. So these are AIAs, and these AIAs are being marked congruent. So guys, if AIAs are congruent, I can say that lines are parallel. So which lines are parallel? Well, obviously it's going to be like this one and this one, the two going in the same direction. Use your common sense. So let's call that like DE is parallel to KC. The reason I knew that is because of what the converse of the AIA's theorem told me. If AIAs are congruent, lines are parallel. So I know this seems like such a small thing, but you do have to say converse AIA theorem. And here's where MathXL might jump in and be your best friend. It'll probably already say converse in it, hopefully. Okay, so if your concluding lines are parallel, that's the converse. Now, the second one says, which lines, if any, must be parallel if 3 and 4 are congruent? So here's 3, here's 4. Same thing, figure out which line does not matter when you're looking at 3 and 4. So I extend 3, and I extend 4, and my colors are getting all jacked up, but it's not that first line there that you're looking at. It's just these two. So 3 and 4. The picture starts to get a little crazy. I notice those are corresponding angles, and if corresponding angles are congruent, I can conclude that lines are parallel. And again, I'm going to use my common sense here. It's got to be the two horizontal ones that look like they're going in the same direction. So that'd be EC and DK. And I know that, and they didn't ask me, but I'm going to say how I knew that. I know that because of the converse of the corresponding angles postulate. Don't you love math? Okay, what about the next one? Let's get a new color here. Highlighter. Which lines, if any, must be parallel if 2 plus 4 equals 180? Hopefully these are SSIs. If SSIs are supplementary, I can say that lines are parallel. So 2 and 4, it's hard to even tell now. There's 2, there's 4. Ooh, okay. So if I extend 4 and I extend 2, I don't use either one of these lines. I just use those two, this one and this one. So basically, there's not even like a pair of lines that could be parallel. There's only 2 lines I'm looking at. Maybe that helps you see a little bit better. I don't use any of these other lines, just those guys. So there's nothing about parallel. Those are just supplementary. They make a line. They're not same side interiors. So I can't tell that any of these lines are parallel. It's not one of my theorems or my postulate. Okay, putting you on the spot, but I want to see if you guys could do this one. Let's jump down to the bottom, though, and look at 2 more examples. So this first one, these are a little bit better. You don't have to write as much of stuff, and there's only 3 lines on this first picture, and that's always going to make it easier if you don't have to figure out what's irrelevant. It just says find the value of x that's going to make L and M parallel. Now, one of these things has to happen. Correspondings have to be congruent, AIAs have to be congruent, or SSIs have to be 180. One of these things has to be true for the lines to be parallel. So I need to make one of these things happen. That's what I'm going to think to like get my x value. So if I look at this picture here, they're talking about this angle and this angle. You guys are going to see this a lot. This is not one of my pairs. They're not corresponding because they're not in the same position, and they're not the interior stuff. So if what they give you is not one of your pairs, think vertical angles. So, and here's what I mean by that. You're going to jump, because you can always jump vertical angles. They're the same. So if this guy's 3x minus 33, so is that one. Now check this out. This angle and this angle, those are corresponding angles. And corresponding angles need to be congruent. So I'm going to set these 2 things equal. And then I just solved this for x real quick. So I'd subtract the 2x over and then add the 33. And x would equal 59. And I knew that because converse corresponding angles postulate. If corresponding angles are equal, I know that those lines are going to be parallel. Okay, last one. It's 4 lines. You only want to look at 3. Now, this is kind of tricky. You need L and M to be parallel, so obviously L and M matter. You cannot get rid of that line. I'm going to get rid of one of them. I need L and M, and I need a transversal that's cutting L and M. So basically, this line is irrelevant, so is the 4x plus 6. Don't get confused by that. Now I look for one of my angle pairs, so this guy and this guy, those are same side interiors. Those need to add to be 180 for those lines to be parallel. So solve that and see if you could tell me what theorem or postulate that is.